For the most part, the equipment that is used to perform TIG welding is similar to that used for other welding methods. For example, a welding machine provides the current used to melt the metal pieces that are to be joined. TIG welding is usually performed with a constant current machine that provides AC and DC welding current. When using DC as the welding current, TIG welding is usually performed by making the electrode negative. This is commonly called direct current straight polarity. When using AC as the welding current, TIG welding machines often use a power supply that provides a high-frequency alternating current to help start, maintain, and stabilize the arc. Like other welding methods, TIG welding uses two cables to carry welding current. The electrode cable has an electrode holder at one end. The electrode holder that's used for TIG welding is commonly called a torch. Even though most of the heat that's generated in TIG welding is in the arc, there is a significant amount in the torch, so a TIG torch must be cooled. The torch can be cooled using either air or water. Generally speaking, torches that operate at less than about 200 amps are air-cooled. Torches that operate at higher current levels are water-cooled. TIG welding electrodes are made of pure tungsten or tungsten alloys with very high melting points. These electrodes are non-consumable. In other words, although they can conduct large amounts of welding current, they do not melt during welding. However, depending on the application, they may need to be changed. As with some other welding methods, if additional metal is needed to fill in the weld, a separate uncoated filler rod is used. The filler metal can be applied manually or semi-automatically using a wire feeder unit. TIG welding, like other welding methods, requires the use of a gas shield to protect the electrode and the weld pool. In TIG welding, shield gas is typically provided from a central gas supply or from portable gas cylinders. Argon, helium, or a mixture of those two gases is most often used. In this part, we looked at the equipment that is commonly used to perform TIG welding. We saw that this method uses a non-consumable tungsten electrode and is commonly performed using direct current straight polarity. Take some time now to try a question about gas tungsten arc welding. In this part, we're going to cover gas metal arc welding. This method is also called metal inert gas welding, which is why you sometimes hear it referred to as MIG welding. MIG welding was developed in the 1940s to improve on two deficiencies of the TIG welding method that was developed several years earlier. With MIG welding, filler metal can be added at a fast rate, primarily because it is fed semi-automatically from a reel rather than manually. Also, at that time, MIG welding was better suited for welding metal thicker than 1/4 inch. Following World War II, MIG welding gained widespread commercial and industrial acceptance and success. For the most part, MIG welding is performed using equipment that is similar to the equipment used for other welding methods. For example, MIG welding uses a welding machine that supplies a constant voltage direct current output. Most MIG welding is performed making the electrode positive, which is called direct current reverse polarity. Like other welding methods, MIG welding uses two cables to carry welding current. The electrode cable carries welding current to the electrode holder. The electrode holder that's used for MIG welding is trigger operated, and because of this, it is commonly called a gun. By operating the trigger, the electrode energizes, the shield gas flows, and the consumable electrode feeds off of its reel. Because MIG welding guns carry electrode wire that's being melted, they need to be cooled. Although most MIG welding guns are air-cooled, some high amperage guns are water-cooled.